in intermediate algebra. When we studied parabolas, the quadratic function, minimizing and maximizing the quadratic function means what? Well, if I look at the picture, if the parabola, because we're looking at something of the form ax squared plus bx plus c, that's my mathematical model, and I need to make it an equation. So we'll make it a y equal ax squared plus bx plus c. They all look the same. It's a U-shaped graph that opens up, or it's a U-shaped graph that opens down. It's one of the two. It's a very predictable mathematical model of something. And if I'm maximizing or minimizing, if I look here at the bottom of the trough, this is your min. If I look here at the top, that's your max. And both of these are found where? Where are them at the vertex, right? One of the things that you can do that can help yourself for this exam, especially if you're going through your homework, is to begin making a list of formulas. And the formula on this exam that'll kill you is the formula for the x-coordinate of the vertex, because the applications are going to be involving, and it will be involved finding maximums and minimums. So that's a formula you're really going to need to know. When you graph, you have to be able to find the x-coordinate of the vertex. So that's going to be that's a big gun as you go through. I have to take a look at some of the rest of the packet. I was thinking about that yesterday, is what are the formulas you really do need to know for this test. I think that's probably the big one of all of the possible formulas. So we now know if it mentions this word, maximum or minimum, biggest or smallest, and my model is quadratic, this means vertex. That you're going to have to find the vertex, because that's where it occurs. So, maximizing revenue. A John Deere company has found that the revenue from the sales of heavy-duty tractors is a function of the unit price that it charges. If the revenue is, and then we say, yippee, hallelujah, they gave me the formula. Woo! And it says, what unit price should be charged to maximize revenue? What unit price must be charged to maximize revenue? If I look at the input variable is P, because that's what's inside the parentheses, and the units is dollars, because it's price. And the output is R of P, and that is revenue, so that's also got to be in dollars. And they didn't tell me that it's thousands of dollars. It just says nothing. So I assume it's dollars. Although tractors, to me, I mean, you're looking at huge prices for tractors, unless they're little miniature baby tractors. But they're heavy-duty baby tractors, I guess. So the first thing it says is what unit price and to maximize. Now, when I look at that, what unit's price, that's X, or we can call it P, but it's X. And maximize means vertex. So that means I'm looking for the x-coordinate of the vertex. or the x-coordinate of the vertex, which in this case is P sub V, the price, is minus B over 2A, and B is 1900, so it's minus 1900 over 2 times A, which is minus 1/2, which is minus 1900 over minus 1, or $1,900. Now, I don't know of a tractor that costs $1,900. What's the unit price? The unit price to maximize revenue is $1,900. So the unit price to maximize revenue is $1,900. Then it says, what is the maximum revenue? Well, max revenue is the Y value. Maximum says vertex. And so I'm looking at the Y coordinate of the vertex, which in this case is R of 1900, which is the X coordinate of the vertex, which is minus 1/2 times 1900 squared plus 1900 times 1900. And instead of being cutesy with this thing, I will just go ahead and use my handy dandy little calculator. I could get cutesy. So negative 1/2 times 1900 squared plus 1900 times 1900 is 1805000. 1805000, which is $1,805,000. So that says that the maximum revenue is $1,805,000. I often will ask you to write your answer in a complete sentence, and that's to help you solidify essentially what you found and what you're looking for.